My project is called the Boredom button because we will be constructing a circuit that delivers a certain amount of amps to the user. This is from a study where people were put in a room and they had nothing to do, and there was a button that they could press that would give them a little shock. And most people pressed it because they hated being bored so much. So the human body is able to withstand from 1 to 5 milliamps without getting actually injured, uh, and a conservative estimate for the resistance of their body is around 2300 ohms. Our circuit will charge a capacitor with batteries, and then the user will operate two switches that will connect between different resistors, uh, so that they can choose whether they want to experience 1, 3, or 5 milliamps. They will push a button that will discharge the capacitor, and the current will flow through whichever set of resistors they chose and then through them, and they will experience different amounts of amperage uh, depending on which one they chose. So after that, they'll release the button, and then the batteries will charge the capacitor again. This is the diagram with the batteries, N representing the number of batteries, the capacitor here, the different resistors, the low resistance, medium resistance, and high resistance, and then the body, which we know the resistance of. So to find the voltage, we can just use Ohm's law, and we find that we need at least 11.5 volts to make 5 milliamps. So we will use 7 batteries with the extra 1.1 volts being dissipated by the resistors. The capacitor we have is definitely the scariest looking part of the circuit, um, but fortunately it doesn't really end up mattering all that much because all it's doing is charging up and then discharging and then charging up and then discharging. And as long as it charges and discharges relatively quickly, it doesn't really matter what capacitance we have because our time constant, which is the only term that includes the capacitance, is just a part of the E value, which just affects the rate at which it will charge and discharge, and also the amount of power stored in it. So that's another reason why we kind of want it small. Um, it'll discharge and charge quickly, and we won't have a lot of power in there. So I'm going to use this capacitor just because it has a nice regular value for capacitance. It is rated for 5.5 volts, so we have to use 3 of them, uh, and that will make our equivalent capacitance this, but again, it doesn't really end up mattering that much. For the resistance, we need to find 3 resistance values that will give us 1, 3, and 5 milliamps respectively for each part of the switch. We find that these end up being 10.3K, 1.9K, and 220 ohms. We will break these up into different configurations of these resistors in different numbers, with these different power ratings, and just making sure that these resistors won't end up, I don't know, blowing up or something. We can check to make sure that the power that is dissipated by each resistor doesn't uh, is not greater than the power rating. So we can calculate the amps that we know they will experience and their resistance to find the power that each of them would be dissipating at a maximum. Uh, all these values are way less than this, so we don't really have to worry about that. So now we can check and see if our circuit does what we want it to. So we have these batteries that have charged up a capacitor, well, I guess 3 capacitors in series, and they will flow through these different sets of resistors and then through the body. So this is the high resistance, so we should expect this reader to say 1 milliamp, and I'll turn this down so that it doesn't go too fast. So that's around 1 milliamp, as we predicted. This charges back up, and then we go through the medium resistance and we should be expecting a value of 3 milliamps, which we end up getting. Finally, we want to get a big shock this time, 5 milliamps. So we will go through this low resistance series of resistors and we end up experiencing 5 milliamps. At pretty close to real speed, though still not that close, it's very fast how quickly these discharge and charge up, especially the capacitors, which is probably due to the low capacitance. So this is what it looks like when going through the other resistors. Finally, really quickly, I just want to mention the references that I used to figure out what kind of amps the human body could take and the conservative estimate for the resistance.